All right, so functional fundamental identities. Basically, this is just kind of tying up some loose ends that we had with this section, and then at the very end, I will go over kind of how this worksheet will work as far as the on the unit circle project. So basically, this is all the stuff we've talked about before, just the reciprocal identity, that sine, the reciprocal is 1 over cosecant. Cosecant is just 1 over sine. It's just that they work in both directions. We've already talked about the quotient identity, and tangent is the same thing as sine over cosine, so that means that cotangent is cosine over sine. So I'm not going to go through this part because we've already hit a lot of this. So really, or I guess part of this where it says given that sine of t is equal to 2 over 5 and cosine of t is equal to the square root of 21 over 5. So remember, like we talked about on Thursday, that all we're going to do here is just use SOHCAHTOA. So if we're going to use SOHCAHTOA, then if sine is of t is opposite over hypotenuse, then that means that the opposite side is 2. The hypotenuse would then be 5. Same way with cosine of t, we're going to have that cosine, remember, of t is adjacent over hypotenuse. We already know that 5 is the hypotenuse. So we already know that 5 is the hypotenuse, so that means that the adjacent side has to be 21. Say hello to Kyler.
Hi.
The adjacent side is the square root of 21. The hypotenuse is still 5. So now we have all three parts of our triangle. Okay? If we go from there, then we can find tangent, which is opposite over adjacent. So if tangent of t is opposite over adjacent, we're just going to find those other remaining trig values. My opposite side is 2. My adjacent side is square root of 21. So again, I still can't leave square root of 21 in the denominator spot, so I would have to rationalize this. So 2 times the square root of 21 over 21. Now, the one thing that I would tell you, or I would suggest, whenever you're doing like the sister functions, so whenever you're doing cosecant or secant or cotangent, like especially for cotangent, I would use this as the one that is going to get flipped and going to have the reciprocal, because there's no need to flip 21 over 2 times the square and make it 21 over 2 times the square root of 21 right here, because that just means I'm going to have to rationalize it. Remember, work smart, not hard, and just flip to find cotangent. All I'm going to do, so to find cotangent of t, all I'm going to do is just flip it and have the square root of 21 over 2. It's going to do the same thing, so that way we have less work that we have to do. Now, whenever we go secant with square root of 21 and 5, yeah, we're going to have to rationalize it. That's going to be okay. But just understand that there are other times we can kind of look, obviously, cosecant with 2 over 5 with sine, and that flipping is just going to be 5 over 2. Okay? But for the most part, so any of the ones that you had to rationalize before, go ahead and just start back at the beginning and go ahead and flip it. Now, whenever we talk about the Pythagorean identities, it's similar to whenever we had Pythagorean theorem. So whenever we had Pythagorean theorem, remember we had a squared plus b squared equals c squared. Well, in this case, we already know what, remember, x is related to our cosine, sine is related to our y, and everything's equal to 1 for our hypotenuse. Remember, everything is a right triangle with the unit circle. So if I have sine of t, okay, and I need to find cosine of t, then I've got to pick basically from one of my Pythagorean identities of basically what I have. Okay? You're going to use what you have and kind of go from there. So I have sine, I have cosine, I have tangent and secant go together, and then cotangent and cosecant go together. So whenever I have sine and cosine given to me, or if that's what I need to find if I have one of them, all I'm going to do, okay, is take sine squared. Okay? Sine squared of t is really just the short way of saying that I'm going to take 3/5 and I'm going to square it, and I'm going to have plus cosine squared t equal to 1. So that's 9 over 25 plus cosine squared of t. I'm going to go ahead and write 1 as 25 over 25. And then all I'm going to do is just subtract. I'm going to subtract 9/25, or 9 over 25, from both sides. So whenever I do, I'm going to have cosine squared t equals 16 over 25. Now, I already know, remember, I'm trying to find what cosine of t is. I already know what the hypotenuse is. I'm realistically trying to find the third side. Okay? And if you can, like, even if you can shortcut this, so like, let's finish here. And then, so if I take the square root of both sides, then I'm going to end up with cosine of t is equal to 4 over 5. Again, this is just a right triangle. Okay? If you notice that this is a right triangle, remember, this is my opposite side, that's my hypotenuse side. Okay? 3 squared plus b squared equals 5 squared. It's still going to be the same thing. I'm still going to have 9 plus b squared equal to 25. I'm going to subtract 9. And then b squared equals 16, so b's equal to 4. Amazingly, that 4 is just right here. Okay? It all fits. It all goes together. Periodic functions really are things that we've already talked about, that if anything, if you go past 2 pi, remember, full circle is 2 pi. If you go past that, then you're just going to go right back to where you originally started. Basically, all it says is that everything happens over and over and over again, no matter how many times you go around the circle. Like every day, the minute hand will go and it will cross the 1 or the 5-minute mark. It'll do it 24 times, and it'll be at the same spot every hour of every day. So it's the same idea. If you go past those values, like 9 pi over 4 with sine, okay, basically it's a matter of paying attention to what you have as far as if it's something over 4. So how many, remember, it's everything over 2 pi. So depending on whatever, so remember 2 pi is going to be equal to 8 pi over 4. It's going to be equal to 6 pi over 3. It's going to be equal to 12 pi over 6. These are all different points depending on whatever your bottom number is, whatever your denominator is that you're given, okay, is all dependent on where it comes from and how you go. Okay, and you're just trying to find the value of each trig function and kind of go from there. So then whenever we talk about repeat behaviors, remember sine is just going to be, it's whatever 2 times, however many times it goes around, okay, full circle. And then cosine, it's just finding, it's just going to be the original spot. Okay, so there's no reason to really overcomplicate anything. And then lastly, using your calculator to evaluate. If it says secant, then if it says any of the sister functions, like secant, cotangent, what you're going to have to do is basically your calculator is only going to let you use sine, cosine, and tangent. You're going to have to, like if you have secant of something, then you're going to have to put 1 over the other function, the original function. So over sine, cosine, and tangent. So whenever I do this, like if I make sure you're in radian mode, so depending on what you have, if you have a scientific calculator, you're going to have to hit the DRG button and make sure it says rad at the top. If you have a scientific or graphing calculator, excuse me, then you're going to have to just make sure you go into mode and it should say degree radian and probably gradient. Just make sure you're in radian mode. I'm here at home, so I can't have access. I don't have access to the graphing calculator because I'm not on the school Wi-Fi. So it's real simple. You're just going to type it straight in, and this is the one time that it's going to let you find the value to 4 decimal places. So that should be able to get you basically the rest of the way through 4.2, and then let me show you kind of what I am wanting on the project.